and at 247 miles an hour it takes off. Those afterburners are on for just over a minute, then they go off. We are well airborne by then. For passengers it almost feels like falling forwards as the afterburners go off. As we go through 290 miles an hour, the nose is moved up to 0 degrees. Then the visor is moved up. Now we can speed up to about Mach 0.95, just under the speed of sound, but not faster, so that there is no sonic boom whilst over land. About 17 minutes after leaving Heathrow, we reached the supersonic climb point over the Bristol Channel. Full power, afterburners go on again, the passengers will feel the surge of power. The afterburners stay on for 8 to 9 minutes until we get through the high drag to 1.7 Mach. Then the afterburners go off. Clever engine and intake design, which this aircraft pioneered and tested, enables the continued acceleration to just over Mach 2, twice the speed of sound, by the time we reach 50,000 feet. And up there it is all very, very smooth. This actual plane is the Concorde speed record holder, as in testing it did 1,450 miles an hour, Mach 2.23, almost 25 miles a minute. That would take us just over a minute and a half from here to central London. Try that on a bus. It could easily overtake a rifle bullet, but at that speed the metal skin got too hot from air friction, about 153 degrees centigrade. Over time, this would lead to metal fatigue. So the maximum speed for airline Concordes was dropped by 100 miles an hour to 1350. That reduced the skin temperature to 127 degrees. Because of this heating up, Concorde expands and is between 6 to 10 inches longer after the transatlantic supersonic sector. After about 2 hours, we are approaching the United States. We mustn't make a supersonic boom over land, particularly over the United States, so 150 miles before the coast we start to slow down, and by 50 miles we are just subsonic. So then we get ready to land. Conventional airliners have flaps on the wings that give extra lift, so they can fly slower for landing. Concorde has no flaps. So to fly slower, it gets extra lift from pitching up the nose about 12 degrees, compared to the 3 degrees for conventional airliners. That means the pilots would lose all forward view again. So the visor goes down, then the nose goes down again to 5 degrees. However, because you remember the whole plane is nose up, the pilot still can't see the runway. So the nose goes down further to 17.5 degrees. Now this amount of droop is exclusive to this. So we're ready to land. And this is the maximum droop that was installed on all the British Airways and Air France Concordes.